So welcome everybody to our next SSbD training organized by the Planets Consortium on SSbD related items. And a very important one, if not the most important one, is how to treat the data coming in from the different dimensions of safety, sustainability, and also functional performance, of course. So we are going to talk about today the multi-criteria decision analysis and methodologies for that. And I would like to thank at the beginning Carla Caldera from Ciensco, Josephine Manch from ELCAM, Neeraj Shandilia from TNO, of course also Beatriz Alfaro Serrano from BNN, and my team here at PLUS for helping with designing it and also for processing, generating materials going out from our project from this training session. So what are we gonna do today? After a short introduction of myself and perspective, basically a little bit, then Carla will give an overview, background on the methodology of this multi-criteria decision making and methodologies for assessment analysis. And Josephine will then also look a little bit with you guys into the tools and methods, show a couple of more sophisticated ones, and then maybe also some simpler ones. And then we can also have some interaction in all of these sections, which we will be facilitating by Menti tools, but we shall also then openly discuss. We're not going to have breakout rooms today, but we can discuss together. We are not a very big group, so this is not an issue I see. On different related items that might be coming up. Then further on, we will look a little bit into what the industry have implemented these days, and we see here two examples. There are other examples of other companies, of course, as well, but we look a little bit into these two. And then we will look into something very specific for our project, because we here in our Planets project take a very stakeholder-focused view. So there are also criteria where we try to involve our stakeholders, and this will be presented by Neeraj then. And then we will going to be wrapping up and concluding and also show the way forward. This is not the only session that we will be spending on MCDA. We have already done some MCDA topics before, and we will at our next consortium meeting in Oyonnax have a very dedicated session also on this topic. All right. So, of course, we talk here about SSbD, about the integration of safety and sustainability with functional performance. And here we have these three different colors by design. Here in yellow, the functionality. I have shown this slide before. We like this slide in a way because it really nicely summarizes what SSbD tries to do. We have shown this in the scoping training, for example. Here, meanwhile, further progression has been conducted at the side of the Commission as well. There is an update, a revision of a recommend, and also the recommendation is out. Meanwhile, following this link, you would be having access to updates of the SSbD framework. This is also a slide that we showed very early in our scoping training already. We were walking through this kind of pie chart, this process at that time, and I wanted to just remind somehow, at that time we did talk about this yellow piece of cake and the blue piece of cake where we integrate assessment, safety and sustainability assessment criteria, eventual data against functionality. So there are also trade-off considerations, normalization, weighting are issues between different criteria that are there in order to decide about a better or worse in comparison to a benchmark. And this is exactly the topic of today, though there will be different mechanisms possible, and we are in the process of deciding which way to take within our project that is most suitable for the cases that we are conducting. There was also a very nice presentation by Neeraj at the Antos about a month ago, where he was also using a polling system with the audience there. All of the people, basically people involved in different SSbD projects. So it was the SSbD community, I could say. And I guess there was also quite some interesting learnings of that to involve somehow views, different views in how to drive such type of decision processes. Again, our project has taken the focus of trying to be very inclusive here and involving stakeholder views as possible. I mean, there are always limitations, of course, how far you can go out. And with this, I would like to give the screen over to Carla, who will now introduce us into the background of MCDA and multi-criteria decision making and show methodologies for that. Carla, stage and screen is yours.
Okay, thank you, Martin. So this will be a simple overview of different approach, and we must say that we have to face decisions with multi-criteria daily, right? So either when we decide to purchase any good, like a new phone, or we want to go traveling and we need to book an hotel in which we need to balance cost, location, if it's clean. Also, when we go to the supermarket to decide on what we're gonna eat. Also when we need to decide our life and regarding our jobs. So there's multi-criteria decision making daily, and as Martin showed in the slide, is also needed in the SSbD context because we have different outcomes. So we have the safety assessment that provides different elements considering intrinsic properties and risk along the life cycle. We have from the environmental part, we have 16 impact categories. So, and from the socioeconomic, also we have different categories that come out the assessment. So we need to somehow decide based on all these outcomes, and so it can be quite complex. And that's why multi-criteria decision making can help. So multi-criteria decision making is a generic term for all the methods that exist that help people make decisions according to the preferences in specific situations when there is conflicting criteria. And so there's also stakeholders that have different views on things. And so this is also indicated for this to bringing together all these different perspectives. It's used for strategic evaluations and decision aiding, so to help to make decisions in complex problems, even when there's high uncertainty. And so this is also important. Of course, that there are different methods, and the selection of the method should be done taking into account the formulation of the problem. A significant advantage of this type of approaches is that it can be applicable to quantitative and qualitative factors. And so there's here some references in case you would like to dig a bit on the different points raised. And so if you would have to get a new car, what will be your decision process? You look into emissions and price, propose an Excel sheet table to compare. That's nice. Consider model type, new versus used. Design, safety, power, price. So you see a lot of criteria that we need to look at. Safety and price again. Price, I think it's very common denominator. Go on an upside that ranks the possibilities based on expert testing. Wow, that's sophisticated. Price quality, price, list and prioritize my requirements. I need to look into its price, family, space. So I guess everyone understands a bit that there are different aspects to look at. So price is definitely something that I go for a green car. I like this color. Oh, that's a unique criteria decision process. That's easy. You are rich, so you can buy whatever you want. That's good. Okay, so I think the point here was to make us reflect on how one of these issues that we would have daily, and that we need to take into account these different aspects. And so some will have more weight than others. Maybe you have some constraints. And that's normally what is behind the multi-criteria decision-making process. And so now I will steal the screen. And so we give you a bit of an overview, not extensive, because we would need many, many hours to go in detail in these things. But normally, multi-criteria decision methods are classified based on the nature of the decision space and the interaction between the criteria. And for example, we can have what is called multi-attribute decision making, that is used for problems with a discrete and finite number of alternatives, as for example, to have a selected job candidate. We also have multi-objective optimization, which is used for continuous decision spaces, where alternatives are defined by constraints. And here, normally, mathematical programming is used. So this is very much used in the logistics, how to allocate resources into this place where things will be located, how it's going to be the transportation. That's very much used there. And we also can classify them based on compensatory, non-compensatory. So there are methods that allow for criteria that are very important to offset something with poor performance. And this, examples of this is the AHP and the simple weighted sum. And non-compensatory that doesn't allow any trade-offs. So in this case, an alternative must meet specific thresholds across all the criteria. And the Electra is a number of, the name of another method that we will look later that is an example of this type of methods. And here is a picture from this paper that kind of like classifies the different MCDA methods. And so as you can see, there are different options to classify them depending on what are the methods capacity. So compensatory, non-compensatory, if we have seen, if we have to do an individual or a group decision, if there is trade-off or not, qualitative or quantitative decisions, if it's within an uncertain or certain environment. And so there's different types of methods. And the choice normally is done depending, as I said before, considering the problem that you have in front of you. It's normally a process that has quite standard steps. Okay, so the first one, we define the goal. So what is clearly state the objective of the decision. So in this case, we could say, I want to buy a car. Identify alternatives and criteria. So in this case, we have 3 cars, for example, and then we have the criteria that you well referred, like price, safety, color also. And then we assign weights. And in this case, the weights to each criteria can be assigned in different ways. So there's different ways to assign weights. So direct rating, that you simply give a weight to the price factor, or you do a pairwise comparison in which you compare 2 criteria like price and safety. And for you, price is 3 times more important than safety, for example. And this will allow to give some weights to the different criteria. Then also the step of normalizing, so you can compare the different things. And there is the calculation that then you use specific algorithms. So each of the methods will have algorithms behind that will be implemented and then will give you the final result. And then it's always good to do some sensitivity analysis to see how the responses would change if we would vary the weights and the scores to have an idea of how robust is the suggestion or the outcome of the method. And so here, for example, one example that we go back to the car of what would be a multi-criteria decision analysis problem. And in this case, we use a very simple approach. So here in this table, as someone suggested, that would do a table. So the table here puts the different criteria: price, safety, efficiency, and design that we have weighted, no? Then we have the different cars, and then we calculate the sum of the weighted factors. So we classify each car for each criteria, and then we okay, so my car 1 scores 8 for price, 4 for safety, 5 for efficiency, 3 for design. And then I multiply these weights for each of these scores. And in the end, I have the sum with the result. So in this case, car 3 would be the one that would be indicated to be selected. And this is a very simple method. Then we can go to more sophisticated stuff. And in this case, we get into a multi-objective optimization. So it's normally you have an objective function that we want to maximize. For example, in this case, if we do the parallel with the car, we want to maximize safety while minimizing price and fuel consumption. So you have normally this type of problem. You have conflicting objectives, so you cannot improve one without worsening the other. And you have some constraints, like say you have some budget constraints or some physical resources. So there is then a possible space of solutions. And in this type of problems, there's normally this Pareto frontier, which is indicated here in the figure in red, in which you can see you cannot improve one objective without worsening the other. Okay, and then this is it's called the Pareto frontier, and you have different Pareto optimal solutions. So this case here, it's something that is a bit more complicated. There's many types of these type of problems also. And if we go a bit on the example of existing methods for the multi-criteria decision analysis, so not these complicated ones with the objective and that. So we have a simple additive weighting. So this was the case we illustrated with the example of the car. So you just evaluate alternatives by multiplying the normalized performance scores by criteria weights. Also, then you calculate the highest score. So this is the most simple approach. Then we have analytic hierarchy processes. So here, instead of just weighting the criteria, there's a pairwise comparison. So is this, you compare the different criteria. So you can say this criteria is much more important for me than that one, and that one compared to the other one. And then you have, that will be impossible to define the outcome considering these different approaches. Another method, and this is a technique for order preference by similarity to ideal solutions. So it's called TOPSIS. And this method allows to rank alternatives based on their geometric distance to an ideal solution and a negative ideal solution. So in this case, the algorithm will work to calculate the distance to this ideal solution, and the closer we are to the ideal solution, the best. Then we have the family of the Prometee preference ranking organization method for enrichment evaluation. In this case, it calculates outranking relations. So outranking relations to provide partial or complete, it depends, there are two approaches, rankings of alternatives. And it uses preference functions to measure the intensity of preference. So here we start to have things a bit more complex, and this will also provide a ranking of the different options. We also have something very much used, which is ELECTRE, so elimination and choice translating reality. Again, it uses outranking relations to compare alternatives by establish at least as good relationships. So this option is at least as good as that one for me. And this allows for partial non-transitive preferences and incomparability. So what is this? Non-transitive preferences is when the choices of an individual do not follow a consistent linear order, such as I can prefer A over B, B over C, but C over A. So there is not consistency in this rational, and so these methods can handle these type of situations. Also can handle incomparability. So there are methods that force a complete ranking. So your option B needs to be outranked by some other alternative, but in this case, there is no need for that. And so they use concordance and discordance tests to determine if enough evidence supports an alternative being better than other. Then we have VCOR. It's another method to solve decision problems with conflicting and non-commensurable criteria. So it assumes that compromise is acceptable for conflict resolution and that the decision maker wants a solution that is the closest to the ideal. So the alternatives are evaluated according to all established criteria. Here we also have ranks of alternatives, and then the solution is named compromise, which is the close to the ideal. So it's similar to the one we saw previous. But this case we have conflicting and non-commensurable criteria. And then we have the whole part of fuzzy multi-criteria decision making. So this case is where there's a combination of fuzzy set theory with decision-making techniques. So all the methods that, maybe not all, but at least some of them, you can combine them with fuzzy theory. So in this case, you can handle subjective, ambiguous, and imprecise data. And so it allows also to decision makers to use expressions like very good, low, instead of exact numbers to evaluate alternatives. And so this is very, very superficial information about different methods that they have then algorithms behind all this that if you are then interested in going to see, you can search for the names, but normally you need MCDA expert can then advise you on what is the best method to use in the specific situation that we have. And so regarding now the multi-criteria decision now is applied to safety and sustainability assessments. So at the time when we did the first framework, we had a multi-criteria decision analysis expert that was making a review of what was applied, what were the different methods applied. And indeed, it's limited number of studies were explicitly addressing both safety and sustainability. So it was mainly to evaluate alternatives like fuels and chemical processes. Many rely on approaches such as the weighted average, as also we saw here, and the analytic hierarchic process. That was the one I mentioned that we do these pairwise comparisons. But we saw that there was very little transparency in the methodological justifications. A major challenge at the time we observed was that the dominance of relative assessments, it's like always comparing, And in that time, the idea to have a more absolute assessment, so we would not need a reference in this case, it adds a bit of complexity to the system to be implemented. In any case, he recommended to adopt a non-compensatory aggregation method. And if this is you can see there in the reference what is proposed. And so and that would be based on decision rules. So this would allow the translation of multiple inputs to discrete rating levels without permitting high performance in one area to offset critical weakness in another. So this was particularly important for the safety part. So the system would need to be made in a way that we would not allow compensation from some criteria to another's. And in this case, it was proposed a composite indicator illustrating how this approach can support this type of complex assessments across different dimensions. In the recent publication of the new framework, so it is referred to this approach, which is an example. So that is the difficulty, because also like now in planets, we have a different context, we have reflected differently, and we will propose another approach because it always depends on the context of the problem we have in face. And also it's also important to have in mind that we can also recur to no aggregation approaches. So other approaches include outranking, dominance analysis, threshold-based filtering, a lot of jargon here, and partial aggregation. So this is described in detail in this publication that you can see other approaches that we have to support these decisions. And interesting also is this recent publication, because there's a lot of discussion around this aspect. And here it gives an overview and recommendations to how to consider in MCDA in SSbD. And indeed, we need guidance, because then in the end, different groups will do different things, and it will then generate results that are not comparable. And so this is, from my side, an overview, very, very light, but then you have the references here if you want to go into details. And now I'm going to give the floor to Josephine.
Yes, thank you for the first part. So now that we have seen a wide overview of what it is, what are the existing tools here, the purpose is also to have some tangible example behind and see what is practice in the chemical industry and then in our industry, so the one involved in Planet. So we already talked about the different type of MCDA tools, and of course they are used in the chemical industry. I must say that typically to the first question, the second question of Carla of do you know MCDA tool? Before preparing the training, I would have answered no, because for me MCDA is actually not something I had in mind. But you will see that in the industry, there are a lot of examples that are actually MCDA. And I hope that also with some example, then the answer to this question will change. So maybe we can also redo it afterwards to see if it changed. Because yes, they are the HAP, the TOPSy, the Victor, and within the company, we use it already first on safety, of course, for every raw material and chemical substitution, to compare hazard between two chemicals. So typically that's day-to-day activities in the industry. Of course, the SSbD, all of the decision of what could we do to integrate eco-design when we are ranking technologies or when we are choosing between two of them, technologies or formulations, and naturally also the portfolio sustainability management, that is a practice more and more used within the industry, which is actually part of the MCDA tool as well. It's the same way of working. So the purpose now is to go maybe from complex to two simple tools and see what are those examples that are today on the market or in use. So we talk about Elect and Prométhée. Actually, those two tools are quite complementary and they are in open source. So if you want to try them, it's easy and possible. So we already went quickly through them, but it's just to show also their specificities. Elect is typically used for ensuring the safety. It's definitely a safety gate. It eliminates the unsafe and non-compliant options. That's why it's a clear gate, because it has also all the REACH and all the other EU chemical policies in the methodology, so it can screen quite quickly. And it's at different level, chemical, materials, formulation, or processes. And what is also quite interesting is that you can play with the threshold on the different part of safety, the toxicity, the persistence, and you can have like that first sensitive analysis. And you can, of course, include some veto criteria where here it's non-negotiable. So already Elect is interesting for safety. And once this one is used, you could use Prométhée, where here it's more used for environmental and eco-design. It is definitely, if you have a look at it and how also the component and the software is made more intuitive and transparent for, I would say, us non-MCDA experts. It clearly rank the different options that you put there, and you can play with the different metrics, the LCA, the cost, or the circularity. It is especially suited for eco-design, as we said, which is complementary with safety just after, and it is to prioritize at R&D the sustainability within your portfolio. So already one of you said that you was using Elect for safety, but Prométhée is also quite used. Another option is also to talk about monetization and have one normalization with price. We're here already on the 15 indicators of LCA, you can play or you can have a normalization with pricing, and you can have one indicator which is linked to price, which is quite convenient often in companies because it's the language, our day-to-day language. Here, the example is the one from Delft, from the Circular Economy Working Group, where in 2024, they updated their version on how to price the different environmental impact. And it is completely aligned with the LCA approach. First, you define your midpoint and your endpoint. And for all of the midpoint, you define a price value here. So you see that now we are not only talking about kilos of CO2 equivalent, but euros per kilo of CO2 equivalent. And always you still have to play with the sensitivity, lower, central, or upper, to have a quite a wider range of it. And you see that at the end, you normalize with money. Actually, in a LCA, sometimes at the end, we normalize on a kilo of CO2. Here, the normalization is made with price, and you can also weight or not the different environmental impact. So here, compared to a LCA, the purpose is to go one step further and to look at pricing. There is another way of including sustainability within your internal processes with money, which is the carbon. Sorry, up. The carbon pricing. I don't know if already some of you are using it. It's a practice more and more done by the industrial, and we see that in 4 years, from 2021 to 2024, there is an increase of 90% of the companies having this tool or this way of doing it. Is that yes, you have still, it's a mono criteria, but you transfer or you translate your project in carbon saving or carbon impact, and you add a price there. It's also more, maybe not regulated, but the best practices are coming into place. The WBCSD published some guidelines on how to do it. And here they recall that it's still voluntary, and it's only to help a company to drive CO2 within already existing decision process, which is often based on cost. And as cost could be or is quite often the only decision, the main or the final, the criteria decision, here to have it there, it's enable to at least always have sustainability and safety at this level of decision. There are different ways of doing it. The shadow pricing, where here you have a price for every emission link. So at the end, the more you emit, the more your price is high. And here it's mainly to raise the awareness. You can have the implicit price, where here on every CapEx or OpEx decision, you ensure to have in your business case also a price criteria. It's enabled to calculate or to integrate in any investment and calculation the environmental once more to ensure that it's part of the trade-off. The last one is internal fees, and here it's more linked to the business and actually the market, where you want to ensure that in any business unit department, they apply a charge on carbon emissions and all of their activities and their products. So it's also enabled to drive and to steer portfolio decision on product and project within BUs, and it helps the company to prioritize or to actually also separate or differentiate the objective for every BUs. And if you want to have more also on how to set it up, the WBCSD is giving more information on this page. On other type of tool, then we went through quite complex ones, and I just wanted to finish with something quite visual, simple. Here I took the example from Quantis. So of course, consulting companies are proposing tools that are aligned with EU ambition for the companies. They are here to support them. So I think it's also good to see what they propose. And we come to quite visual management to have multi-criteria decision. Typically, to have product portfolio segmentation, having on the axis something with an eco score and on the other one a price or a sales, it's enabled to decorrelate environmental to price, but still have the two of them on the same graphic. And here you can also decide on action for that. Typically, you have a good eco score and you have a good sales potential, then you are already, let's say, on top, but you don't need to put any marketing or eco design effort. However, if you have something which has a low eco score and a low sales, in prioritization, it could be quite easy to say, okay, let's stop it, or at least don't put any effort on it. Let's deprioritize it. And there is those gray area where you have not a so good eco score, but at the same time not so good sales. What do you want to do? Is it a priority? Is it not? What do we remain? What is also interesting is the one in orange, where you have a low eco score, but a quite good sales potential. That's actually where you should, in theory, put most of your resources to upgrade, to improve this sustainability dimension and ensure that your business will be on the right projects. So here, actually, it's already quite visual, easy, and have two criteria, self and eco score, but behind eco score, you can already have the different SSbD criteria. And then one which is pretty basic, which are spider diagram, where you can have all the eco design strategies axes all on them, and you can compare a new product versus a reference during all along the life cycles. So here, I'm actually pretty sure that in the companies we are using such tools, and that yes, MCDA is actually used in most of the companies. On the example, then we wanted to go a bit more on R&D and what we are doing within the consortium as well. And how do we approach it? First, with the PSE, so Portfolio Sustainability Assessment, which is once more proposed by the WBCSD, that enable to integrate sustainability within all the steps of a product development, a product or a process. We already discussed about it. I'm sure you know it because it's a best practices of other tools, typically the one that is coming after from ScienceCo. And it's really adaptive to all type of industry. And at the end, after defining your scope, having the different segments, once more you go to the signals and you categorize, you can have an eco score and you can segment, you can differentiate your portfolio. But how actually it is a MCDA tool? We go back a bit to the definition of MCDA. When it comes to the alternative you define at the beginning, in the PSA, you look at, is it a product, a project, a technology? From the different criteria that exist in MCDA, in the PSA, you have the circularity, you have the climate, energy, but also the financial ones, such as cost, the risk, the value. So really take into account all of it. You can have different way of weighting it. And here, typically priorities, SBTA, so the science-based targets, or risk tolerances. It's also nice to sometimes not have a weight on business potential, but also on the risk for ecosystem, but the risk for, I would say, financial ecosystem. And when it comes to the scoring, KPIs, target, and so on, and the decision, of course, you can either prioritize, you can also rank, you could stop, you could phase out. So you really put the different things. So once more here, it's showing that tools that we are practicing, we are using are MCDA tools, and definitely they are adapted to SSbD. So here the purpose was to go on WBCSD, the PSA1, but let's look at a practical example that Carla will show from the one on ScienceCo.
You can just skip the slide and I'll go.
Yeah, sure.
So here is a presentation of how we do at ScienceCo, how we deal with these different criteria. So normally we look at the packs. So it's like a product representative of a specific group segment of products. And we do two things. On one hand, we calculate, so we perform an LCA, cradle to gate, of this product. And we monetize the impact categories. So we have shadow costs for all the 16 impact categories. And we balance then this result with economic value that this product will bring to the society. And this, we call it operational vulnerability. So when we calculate this, this will go represented in the y-axis of this figure that you see on this heat map. This figure has different areas. So then depending on where the solution is, the pack is positioned, it will be a solution, a challenge, or something that we need to work on. And so we have on one hand the operational vulnerability, in which use the monetization. On the other hand, we have market alignment. So we look at the products in application, right? So while in the operational vulnerability, we have just cradle to gate, in the market alignment, we have qualitative questions that look at the performance of our product in a specific application around 4 themes: health and safety, climate change, resources, and opinion leaders. And in this case, we don't do any aggregation, anything. So we do the questions. We check the questions for that specific product. And if at some point we find a challenge, we stop there. Okay, so we don't allow to have, so it's a more rigid approach as we were seeing before for the safety, you know, but and so this is then the combination of these two results is then positioning the pack in this matrix that you see there. And so we want to have products that are positioned in the upper right corner of this graph because they are considered as a solution. And so that is how we deal. So this is the sustainable portfolio management guidance you have there if you want to have a look. But this was a translation of the PSA into the Solvay at the time practices, and now ScienceCo. And different companies have different approaches. BASF has a triple S and others, and this is the way we do it.
So now I would like to hand up the floor for the next part on why and how to include stakeholder views.
Okay, so the stakeholders part. So we heard about MCDA. What is it? We heard about the general practices being used within the industry for the MCDA. Now, a third perspective is about this stakeholder views, where exactly the stakeholders fit in. Now, for some of you, it might be quite obvious, but I think it's an integral part of the entire decision making, which we need to discuss along the process and incorporate it within our decision making as soon as possible, as meticulously as possible, given the limited resources. So in March, we had this workshop on the stakeholders. So from there, we had a quite good idea about what are the stakeholders we normally should consider within the MCDA process. But just to make sure here that the stakeholders here, what we mean is that anyone who makes the decision is affected by it or has relevant knowledge. Now, this knowledge can be from technical experts to the industry or to the regulators. Value chain actors, they very well, and then the users themselves of the product that you are putting in the market, and of course, the society at large. Now, the essential question is why? Why do we need to involve these stakeholders into the decision making? Now, there are several key reasons. The first is, of course, their input helps ensure that the design solutions that we develop, they are relevant and more likely to be accepted in practice. So without their perspective, we risk designing solutions that look good on the paper, but they fail in reality. The second reason could be that the stakeholders help capture all dimensions of safety and sustainability by design, which includes safety, environmental impact, social impact, economic impact, and the functional aspects. They also bring real-world insight into trade-offs, such as balancing cost with sustainability. And finally, involving the stakeholders increases transparency and builds trust in the decision-making process. So that's why it's very important to have these stakeholder perspective within the decision-making process. Now we move to the next part, how one can think of. And I think the March workshop was a very good example on how to get these stakeholder views, their perspective incorporated into the entire process. Now, this participation of the stakeholders that can happen at several stages. They may contribute to structuring the problem itself, defining the possible alternatives, and setting criteria and their relative importance or weights. Now, this involvement is usually facilitated through methods such as workshops, interviews, or decision conferencing, which allow for structured and interactive engagement. The third question is in terms of benefits, like what do we gain from such involvement? Stakeholder involvement, it definitely leads to better and more robust decisions because it integrates diverse knowledge and perspectives, which might be sometimes obscure to a certain decision maker or to a company or to a regulator or any other stakeholder. So it also enhances transparency, legitimacy, and accountability, which are critical for decisions that may affect multiple groups. And finally, it improves engagement and can help prevent or resolve conflicts early in the process. So we see a lot of benefits when it comes to the stakeholder engagement within the decision making. But of course, there are certain challenges, and the effective stakeholder involvement requires careful structuring and facilitation to ensure meaningful participation. And these type of the challenge we also encountered during the workshop, during the entire project, Planets project, that we will also talk about next week when we meet in Oyonnax. The stakeholder engagement can also be difficult to balance expert input with accessibility for non-experts, which makes it important to design processes that are both rigorous and inclusive. And overall, stakeholder involvement is not just beneficial, it is essential for making well-rounded, credible, and implementable decisions within MCDA. So this is basically the bottom line when it comes to the stakeholder involvement. Here I wanted to give you some idea about within the planets, how are we thinking of including these stakeholder inputs within the decision making. Our main aim is to systematically integrate the stakeholder views, criteria, or perspective, whatever you want to call it, into the decision making. Now, the key idea is that the stakeholder perspective are not just collected qualitatively, they are also translated into quantitative thresholds and tolerance limits. This makes it possible to directly include them in multi-objective optimization. So the point that Carl already talked about, and it is this multi-objective optimization is a sort of a, can say, a precursor when it comes to the multi-criteria decision analysis, where you have this optimized design solutions. And therefore, the stakeholder perspectives, they are directly incorporated within these multi-objective optimization. Now, when we look at the process step by step in the image, which you see on the right-hand side of the screen. So first we start collecting the stakeholder criteria. Now, this is what we did in March. This is typically done through workshops, surveys, or interviews where stakeholders express what matters to them. So the safety, cost, environmental impact, or performance. The second step is about the inputs themselves. They're translated into measurable criteria. For example, a qualitative preference like low cost might become cost less than or equal to 110% of a benchmark. And that's what we also saw during the workshop in March, that many of these stakeholder criteria, they were very, very qualitative and highly subjective. They were missing these figures, these thresholds. So we have to, this is a big challenge when it comes to incorporating these stakeholder views into the decision making, how to translate these qualitative values into the quantitative ones. So, and that makes it easier actually for this decision making process. The consumer might say that I want a safe product, but what does this mean exactly? It might mean that excluding substances that are classified as carcinogenic, mutagenic, or reprotoxic class 1A or 1B. So it's all about translating them into quantitative limits and bridging the subjective views with the quantitative analysis. The third step is that we define the cutoff criteria, so which act as the minimum requirements. Now, these are the thresholds that options must meet. So the design solutions must meet to consider acceptable. And these are your electrostyle thresholds, if I remember correctly, where you have non-compensation. So if the cutoff has to be satisfied. So basically, it's filtering out the unacceptable solutions early on. The fourth step is about the tolerance limit. Now, this was also one of the important outcomes from the workshop last month, that we need to work with the tolerance limits, because at an early early innovation process, so a design solution that does not really look that promising might turn out promising as the technology advances. So we need to assign certain tolerance limits, and these tolerance limits can be quite lenient, to start with. And as we go along the process of the innovation, they can get more and more stringent. So with such a process, we introduce flexibility around the thresholds, reflecting that stakeholder preferences are not always absolute. And this we also saw that consumer perspective or even the investor's perspective, they change over the time. So, and also as an example, a cost increase at 10 to 25% might still be acceptable, or performance may need to stay within a certain range. So it's all about assigning these tolerance limits. And of course, higher the stringency in your tolerance limit, higher the strictness of your tolerance limit, lesser are the optimal design solutions that you're left with. And finally, all of this is integrated into the multi-objective optimization framework. So the stakeholder defined cutoffs, they become constraints, while the measurable criteria are used to optimize across multiple objectives. And this helps define you a solution space, an optimized design solution space that is both technically feasible and aligned with stakeholder expectations. So the bottom line is the planners approach essentially translate these stakeholder values into numbers that can directly guide optimization and decision making. Now, such an optimization doesn't just give one best solution. Life is never easy like that. So instead, it identifies a set of good solutions that balance different objectives like cost, safety, performance. So looking at that example of the car, you might have a car that costs a lot but provides you a lot of safety, or the other way around. And while talking about these objectives, improving one would mean compromising the other. So this is where Pareto optimization comes in, and which means identifying solutions which you can't improve one aspect without making another worse. Or in simpler terms, it helps you see the best possible trade-offs. So we have to do this trade-offs into this multi-objective optimization process. And finally, I wanted to show you.
Sorry, just one question. There is one question
Yeah.
in the chat that you might want to answer here.
Yeah, I can also just talk. Hey, Neeraj, I had a question. Do you also think that the stakeholders should be included in determining the weight or importance between the dimensions?
Sure. Yeah,
Okay.
yeah. Okay. Yeah, definitely. So for example, there can be some non-compensatory criteria that the stakeholders can't live without. So cost, for example, can be a big motivating factor right there. But also the regulatory constraints, they are also quite, they should have highest weight somehow. So either pass or fail. But then there are these objectives or these criteria that you can optimize upon, that you can improve over the time. So making, I don't know, color less red, more that, blah, 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 those type of things, because it helps the consumer see it better, or aesthetic, for example, those visibility type of thing. So the idea is that depending on the stakeholder, these weights, they change. And of course, there are many market studies, these trends that provide you such insight into what works, what doesn't work, basically. And it's up to the decision makers themselves to define these stakeholder groups that they deem relevant for their, because we saw in the question that majority of the responses, they say it depends. And this really complicates the things. So up to the decision maker, it's up to the decision maker to identify these stakeholder groups first and talk to them. Okay, what works, what doesn't work? And most of the time they already have an idea. So for my stakeholder, this would work and this wouldn't work. And when it comes to the, for example, people like regulators, we already know regulations are well defined. Investors, most of the times they care about profitability, scalability. So sometimes we already know how the stakeholders are thinking along the process, unless it's a very disruptive technology, putting something new in the market, or those type of things. If anyone wants to jump in, feel free, because I'm not an MCD expert or an MOO expert. It all depends on like how I perceive this entire process. Yes, Martin.
I would maybe like to not add something, but maybe throw something in. Like, I mean, with the weighting, we actually have the opportunity to combine compensatory and non-compensatory methodologies in a way. Just by adding a very high weight to something, we make it non-compensatory, right?
Yep. I can tell you one thing, that when it comes to the non-compensatory criteria, either you consider them as a screening criteria, a very first screening criteria, that all those design solutions which satisfy this non-compensatory criteria, they go through this screen, and others one are simply left out. And they can very well be the regulations themselves, because and other things as well. So this can be one of the ways to deal with this. Looking at the time, I will go. This is my last slide. So this is an illustrative example that I want to show you, okay, how one can think of it. So here I want to show you, okay, how what the output looks like once the stakeholder inputs have been translated and integrated into the optimization framework. So this is a line diagram. So on the left-hand side, you see different criteria with limits. Huh? So when you consult with these stakeholders, what sort of criteria do you identify? And you assign these limits, these tolerance limits. And so these are quantitative thresholds derived from the stakeholder preferences, such as minimum performance levels, maximum acceptable costs, etc. So these are actually constraints or filters, meaning that any solution that doesn't meet them is automatically excluded. Of course, the tolerance limits that you define will also define how the filtering out or filtering in of these solutions. So basically, this step defines the acceptable solution space. So, and on the right-hand side, you see this optimized design solution across multiple dimensions. So each vertical line here, so they represent a dimension like safety, environmental impact, economic impact, social impact, and functionality. And the colored lines that you see, the zigzag lines, each of the line, they represent different design solutions. So you can clearly see how each solution scores for each dimension. So the nodes that you see on these vertical lines, these are the scores for each dimension. So what's important here to understand is that none of the solution is universally best. Instead, they each represent a different balance of trade-offs. For example, one solution might perform very well environmentally, but slightly more expensive, while another might be more cost efficient, but less strong on the social impact. So this is where such visualization of the multi-objective optimization comes in, where we identify a set of best compromise solutions, meaning you can't improve one aspect without making another worse. So of course, the next step would be a Pareto optimization. So rather than forcing a single answer, this approach gives decision makers a portfolio of high quality options, which are all aligned with stakeholder defined criteria. The final choice then can be up to the decision maker based on his or her priorities, context, strategic goals. So the company can decide, okay, as part of these my priorities, my context or strategic goals, these are the solutions that I want to go for. So in short, the stakeholders define what is acceptable, and the model here or this visualization shows the best possible ways to achieve it. So it's just this illustrative example. And I think that's it from my side.
Yes, thanks a lot, Neeraj. I will steal the screen just for a very few moments, because I have a kind of summary conclusion or take-home message in a way. So thanks to all the presenters and for introducing us and other people maybe then in future as well to MCDA, so multi-criteria decision making, let's say. We have covered a number of nice things. We were also learning about some very clear methodologies that are out there. But nevertheless, we still have to probably get a bit more view into this kind of things. But what we have seen is actually what basically MCDA is, what it differentiates to multi-objective optimization. We talked a bit more on optimization than towards the end, and what it could be used for and what we would basically need for it. Of course, there are many methodologies out there, and there is much more detail. This was just a kind of introduction today. We talked a bit about compensatory versus non-compensatory methodologies and how they kind of can be linked, even with weighting, for example. Yeah, thanks for Josephine, who gave us also some nice insight in these tools. Even we could have the chance to look a little bit what industry currently applies for. Probably knowing that this is MCDA in the end, but of course it is type of things. Decision making is a daily process that we need every day. Yeah, and then the monetization methods are quite interesting, to put everything down into coins and money, basically. We discussed this also a little bit, and then we finalized here with the stakeholder criteria input. And this is not over now. This is an ongoing discussion, and further progress will be made. And I guess we went into that now, and we are looking forward now also to what's next. So we will have in Oyonnax, mentioned it, Neeraj mentioned it, the next workshop where we dealing with this more in detail, even in order to be able to define a nice methodology for us to establish a decision support system and have all the kind of basics together on what it could be built on to enable flexible and adaptable and well-fitting decision making for us in project. So I guess normalization, scoring, aggregation, how to deal with uncertainty, visualization, these are important issues and details to be talked about. Thanks a lot to Carla, to Josephine, to Neeraj, to Beatriz for presenting today. Are there questions, comments, concerns at this stage?
Thank you, Martin, as well.
Yes, you're welcome.
Thank
My
you.
pleasure. If we have no comments today, I guess we look forward now to the next step. And this is not the last and single opportunity that we have been talking about that. Yeah, and if anybody needs or wants to know more about our project and our other training resources on SSbD, here is the web page. Lots of things are already established there, and more will come. With this, I would like to wish you a nice weekend and see you soon.